Search and social media platforms have changed how journalism content is being consumed and distributed. These platforms, driven by algorithms, automation, and artificial intelligence, have had significant impacts on the information gatekeeping role of news organizations. Younger audiences in particular have turned away from traditional forms of journalism distribution, such as newspapers, television, and radio, relying increasingly on social media platforms such as Facebook and Twitter to learn about world events. In the face of this, how can news organizations compete and remain relevant? One possible approach would be to embrace these platforms' adoption of automated and personalized content distribution. At its simplest, personalized news examines the past consumption patterns of users, their peers, and people similar to them in an effort to recommend content and products that are most relevant to their interests. Within the field of journalism, research has shown that audiences have a slight preference for news chosen by algorithmic systems based upon their past user consumption over that of editor-chosen stories. This preference for personalization becomes even more pronounced with younger audiences and users that consume news on mobile devices. My work specifically examines how emerging text-to-speech technologies could be combined with news personalization techniques to deliver automated audio-based news bulletins. With the creation of our prototype BulletinBot, a simple automated news bulletin system, my research explores how news organizations could automate elements of the news delivery process and illustrates some issues that surround this approach. Within a radio context, news bulletins are short summaries of important news items. Featuring a few items, usually 30 seconds each in length, bulletins quickly get listeners up to speed on what is going on in the world. Before we talk about how text-to-speech could automate this work, let's explore its evolution. Since the introduction of the first text-to-speech systems in the 1960s, scientists have strived to create computational systems that synthesize text into audio which mimics the sound of human voices. The results of such technologies were often underwhelming. While comprehensible, most speech synthesis systems featured robotic and tinny-sounded voices that no one would mistake for human. But advancements in AI-based machine learning and neural network approaches to text-to-speech over the last decade have ushered in a new era of realistic-sounding automated speech. Computing platforms such as IBM Watson, Google Cloud, Amazon AWS, and Microsoft Azure have introduced simple and affordable cloud-based implementations of text-to-speech systems. For example, listen to this example of a machine learning-based text-to-speech approach.
There were many editions of these works still being used in the 19th century.
As the complexity of text-to-speech systems have evolved, academic researchers have focused on the ideal design characteristics of speech synthesis systems and the social issues that use of such systems present. Not surprisingly, Camber et al. Explained that research has shown that the quality of a synthesized voice has a significant impact on the user experience. Somewhat counterintuitively, Camber et al. Also found that creating a synthesized voice that was too human-like may cause confusion and mismatch expectation among users. Studies have also found that audiences have an affinity for speech that mirrors their own. As speech synthesis becomes more lifelike, concerns have risen about the ethical impact of its use. Camber et al. Outlined that voice is a powerful medium for persuasion, and in a digital space where fake news has become a growing challenge, putting realistic-sounding artificial voices in the hands of bad actors is an issue of concern. Bendel explained that sampling techniques which allow the recreation of voices of individuals without their consent could allow for the creation of false narratives. Ensuring that digitized voices present a diverse representation of nationalities, genders, and languages has also been identified as an important design characteristic of both text-to-speech systems and applications developed with them. Again, Camber et al. Revealed a disheartening confirmation of prior studies which showed that male voices received higher quality ratings than synthesized female voices. This and other research shows that the social impacts of text-to-speech technology could be significant, but the explorations of this impact within the journalism industry are limited. It is hoped that the continued development of our BulletinBot automated news bulletin system might spur further interest in this research topic from a journalism perspective. Developed using the Python programming language, BulletinBot's personalized approach centers around a pair of article corpora that represent both an archive of news items and a separate corpora that also represents a selection of articles that a hypothetical user has previously read. These news articles have been scraped from the website of the CBC, and each corpora and the associated article data are stored in a separate, comma-separated text file. By comparing the corpus of articles that a user has previously read to the larger corpus of all news articles, a list of recommended articles from the news archive are selected. Our personalization approach uses a rather basic but common technique used in information retrieval studies of employing term frequency inverse document frequency measures alongside cosine similarity calculations to determine the similarity between our user's perceived interests, as represented in the user interest corpus, to the larger archive of articles. A sample of how this works can be seen in broad strokes on these slides. On this slide, for the similarity measure, the closer the number is to 1, the more similar the article would be to our user's interests. You can see generally that our recommender recommends articles about soccer, as the user has mostly read articles related to soccer. A simple news bulletin script is created from the top 5 articles that most match the user's interests by combining each article's lead with a small amount of speech synthesis markup language code. This text-based script can then be synthesized into speech using either a text-to-speech conversion Python library or IBM Watson's paid text-to-speech service for perhaps more realistic voice reproduction. In both cases, results are saved as an MP3 audio file. Here's a small sample of the results.
The Montreal Impact are headed to the round of 16 at the MLS's back tournament. The Impact, 1-2-0 in Group C play.
A significant limitation of our system's design is the repurposing of content that was not originally designed to be used in a radio script. Text-to-speech synthesis also occasionally misses some of the nuances of human speech that would be easily handled by a human newsreader. While the cloud-based text-to-speech systems perform better in this regard, the more simplified Python library struggles to understand when reading a sports score that is written as 12-6 that it should be synthesized as 12-6 rather than 12-6. Human readers are also adept at naturally shifting the tone, speed, and cadence of their voice depending on the context of what is being read. For example, while reading the account of a tragic event, a somber tone can be taken, while a more upbeat approach could be used announcing the birth of a child. The current design of our prototype synthesizes all scripts with the same tone and sounds, which is a little bit monotone in nature. Text that employs speech synthesis markup language could replicate some of the human voice shifts in a text-to-speech system, but automating the creation of such scripts would be challenging. Like many automated systems used in journalism, the most effective implementation of our automated news bulletin system would entail a hybrid human-machine approach, and a key element of such a hybrid approach would be atomization. Atomization, as explored by Jones and Jones, would see news stories broken into distinct atoms of information, which then could be rebuilt and repurposed in other forms. One example of an atom could be, for example, the key elements of a story, which could then be combined to form a brief news summary, which might work a little bit better than our approach of using the lead to build the script. Even with its simple approach, our prototype shows the potential of what a more complex implementation of an automated news bulletin system could offer a news organization. One challenge of a radio news bulletin is how, in a limited amount of time, to share information that is relevant to a user's interest. One audience, for example, might be more interested in sports, while another audience member might want the latest business news. A personalized approach ensures that content is relevant to audiences and might lead to longer and more consistent listening. An automated news bulletin also allows for on-demand listening. Audiences would no longer need to wait until, for example, the top of the hour for their latest news. For example, if such a system was integrated into a smart speaker, getting a personalized news bulletin could be simple as saying, "Hey Alexa, what is the latest news?" The move from a traditional scheduled broadcast model to an on-demand listening could open up programming into new audiences whose schedules don't allow for regular listening. From a cost perspective, advances in text-to-speech technologies could allow financially strapped newsrooms to deploy resources dedicated to news reading positions to other areas. The limitations of our basic prototype have also shown how a news organization might have to adapt their processes to implement a truly effective automated news bulletin system. By adopting a human-led adaptation approach to their news content creation, news organizations could facilitate the repurposing of their content, leading to more novel ways to distribute their journalism. An automated and personalized approach to news delivery, a prototype of which is shown with their news bulletin system, could help journalism reach new audiences and provide a level of coverage impossible with human news workers alone.